Hello everyone. Now in this video we are going to learn about linear independent and linear dependent vectors. Now look at the definition first. Let x1, x2, x3 and so on xn are vectors are said to be linear independent. Then there exists c1, c2, c3 and so on cn are constants such that c1 x1 plus c2 x2 plus c3 x3 plus and so on cn xn equal to 0. Now this is the linear combination of all these vectors 0, where ci equal to 0 for each I equal to 0. Each I. Okay. Now it means that all constants c1, c2, c3, c4 and so on cn all are zeros where ci equal to 0 for each I. Okay. Now each I nothing but where I equal to 1 c1, I equal to c2, I equal to c3, c3 like c1, c2, c3, c4 and so on cn all c's are 0. Then x1, x2, x3, x4 and so on xn are linearly independent vectors. Okay. Then if they are dependent, if we say for the existing for n constant c1, c2, c3 and so on cn are constant such that c1 x1 plus c2 x2 plus c3 x3 plus and so on cn xn equals 0, where ci not equal to 0 for any I. It means that one of the c should not equal 0. It may be 1c, it may be 2c or 3c, any c not equal to 0. At least one. It means that at least one c not equal to 0. Then the vectors x1, x2, x3 and so on xn are linearly dependent. Okay. Now if all c's are 0, then is linearly independent. If one of the c is not equal to 0, is linearly dependent. Okay. Now these are the definition for linear independent and dependent vectors. Now next look at the problem whether you understood clearly. Our vector 2 2 1, other vector minus 4 6 5 and other one minus 2 8 6 are linearly dependent. If so, they are dependent, then find the relation between them. If they are independent nothing but there is no relation, right? They are independent. Okay. They are not dependent one on another. But dependent, it should be dependent on other. One vector maybe depends on other, or two vectors are depends on other. Now it should be then combination we have the dependency. But if it is dependent, then find the relation. If it is independent, no need to find the relation. Okay. Now first show it they are linearly dependent or not. Okay. First let for the vectors like first vector as x1, second vector as x2, third vector as x3. Okay. Now there must be existed three constants c1, c2, c3 such that c1 x1 plus c2 x2 plus c3 x3 equal to 0. Now this I let for equation star. Okay. Now if you c1, c2, c3 is 0, c1 0 and c2 0 and c3 0, then x1, x2, x2 are linearly x1, x2, x3 are linearly independent. If one of the c is not equal to 0, then x1, x2, x3 are linearly dependent. Okay. Now first substitute for x1 and x2 here and x3 here. Now write the equations here. 2c1 plus minus 4 into c2 is minus 4 c2 and minus 2 into c3 is minus 2 c3 equal to 0. Now next 2c1 plus 6c2 plus 8c3 equal to 0. Now c1 plus 5c2 plus 6c3 equals 0. Now this is a system of equations, right? Now it says that homogeneous system, right? Homogeneous system of equation where variables are c1, c2, c3. In a homogeneous system, you have the two cases that if you may be having infinite number of solution, it may be having unique solution. What is a unique solution? Unique solution should be a zero solution, right? Now zero solution nothing but all the variables equal to 0. Now if this homogeneous system having zero solution, like where c1 equals 0, c2 equals 0, c3 equals 0, nothing but all c1, c2, c3 0, then x1, x2, x3 has linearly independent. It means that the homogeneous system has a unique solution, then the given system has then the given vectors are linearly independent. If then this homogeneous system has an infinite number of solution. For infinite number of solution, in our last lecture we discussed that if it is infinite number of solution, then one should be a parameter, right? One should be not equal to 0. Okay, now it should be not equal 0. If not equal 0, then one of the c not equal 0. Therefore the x1, x2, x3 are linearly dependent. Okay, now try to get the solution of this homogeneous system now. Okay, for this homogeneous system, simply I go for the matrix form. X equals 0, then A matrix, and variable matrix here C1, C2, C3 equal to 0. Now consider A matrix here. Now try to find out the rank of this by using echelon form. If the rank of A equal to number of unknowns, if it is unique solution, rank of A not equal to number of unknowns, infinite number of solutions, right? Now use the operations here. R2 changes to R2 minus R1. Now R3 changes to R3, become 2 minus here 2, minus R1. Now first row is same, no changes. Now here 2 minus 2 0. Now 6 minus half minus 4 is plus 4. 6 plus 4 is 10. Now 8 minus half minus 2 is plus 2. 8 plus 2 is 10. Now next here R3 changes to 2 R3. 2 minus 2 is 0. Now 2 5s are 10 minus 4. Now minus of minus 4 plus 4. 10 plus 4 is 14. Now 6 2s are 12. Minus of minus 2 is plus 2. 12 plus 2 is 14. Now make it this is 0. Now R3 changes to, now multiply with the 5. 14 5s are 70. And 7 10s are 70. Now become 0. Now R3 changes to 5 R3 minus 7 R2. Now first row, second row same. Now third row 0, 5 into 0 minus 7 into 0 is 0. Okay. Now next 14 5s are 70 minus 7 to 10s are 70. 70 minus 70 is 0. Now similarly here 70 minus 70 is 0. Now we have the echelon form. This rank of A is 2. Number of unknowns are 3. Then they are not equal. The system has a infinity number of solution. For infinite number of solution, then should be linearly dependent, right? For a unique solution, then all C1, C2, C3 equal 0, linearly independent. They are not equal, right? Should be infinite number of solution. They are linearly dependent. Now if it is dependent, we need to find out the relation between them. To find that, write the reduced equations here. Now 2c1 plus 4c2 minus 2c3 equals 0. 10c2 plus 10c3 equals 0. That is the equation number 1 and 2. I will rewrite that to equation 1 and 2 here. Now let for c3 equal to alpha. Now that you substitute in equation number 2, get for c2. Okay. Now c3 I let for here alpha. Now substitute here, get for c2. Now here alpha, come here minus 10 alpha. 10 cancel. 1 c2 equal to minus c3. Now c3 is alpha, therefore c2 is minus alpha. Now c2 is minus alpha and c1 alpha substitute in 1. Then 1 implies 2c1 minus alpha, here minus into minus plus, plus 4 alpha, minus 2 into c3 is alpha. Alpha equals 0. Now 2c1 plus 4 alpha minus 2 alpha is plus 2 alpha equals 0. c1 equal to alpha. Now x is the solution c1, c2, c3 minus alpha, alpha, alpha. Now then here, then c1, c2 can't be zeros, right? Now c3 we are taking for a parameter alpha. C3 we are taking a parameter alpha, right? Now is not equal to 0. Okay. Now one of the c3 c values is not equal to 0. Therefore they are linearly dependent. That's why also we can conclude it. Now c1 is minus alpha, c2 is minus alpha. Now c3 is alpha. Now substitute in equation number star. Okay, now in this c1 x1 plus c2 x2 plus c2 x3, c3 x3. Now substitute that. Again get c1 x1. c1 is minus alpha x1 plus c2 x2. Now minus alpha x2 plus c3 x3 alpha x3 equal to 0. Now my alpha here, alpha common, make it 0. Now these two terms write it here one side as c1 x1 plus c2 x2 plus c2. C1 C2 is alpha values, then alpha x1 plus alpha x2 plus equal to alpha x3. Now alpha will cancel both sides, then x1 plus x2 equal to x3. Now this is a relation we have in between three vectors, that is x1 plus x2 equal to x3. Then better you verify it is it right or wrong. C1 x1 plus x2 equal to x3. Now x1 x2 x1 plus x2 equal to x3. Now 2 plus minus 4 is minus 2, which is same as x3. Now 2 plus 6 is 8, which is same as x3. Now 1 plus 5 is 6, which is same as 6. Now like that we can have a verification for the relation x1 plus x2 equal to x3. Now this is a way to find